Hello viewers, welcome to IT Maths. In today's video we'll be looking at highest common factor. So before us we have two questions. The first one is find the highest common factor of 6, 12 and 18, and the second one is find the highest common factor of 18, 24 and 42. We'll be approaching these questions in three different ways. The first method is the easiest to understand, and the third is the fastest. I'll always recommend the third. Well, the second helps you understand the third, so that's why I'm going to pass through the second method. Please, before we continue, kindly click the subscribe button down there. It helps me a lot. Thank you. Now let's begin. Find the highest common factor of 6, 12 and 18. We'll begin by first finding the factors of 6, 12 and 18. What are the factors of 6? If you've not watched our previous video, please kindly go and watch it, and then you'll find out how to easily get the factors of numbers. So 1 times what gives 6? 1 times 6 gives 6. So 1 and 6 are factors of 6. The next higher number is 2. 2 times what gives 6? 2 times 3 gives 6. What's the next higher number? 3. 3 times 2 gives 6. But already we have 2 times 3. So 3 times 2 is the same as 2 times 3. So we don't go any further. We've gotten to the end of our factors. Next, 12. What are the factors of 12? We begin with the smallest number again, 1. 1 times 12 gives 12. The next higher number, 2 times 6 gives 12. The next one is 3 times 4 gives 12. And the next is 4 times 3 gives 12. But 3 times 4 is already here, so we've gotten to the end. Now, let's go to 18. 1 times 18 gives 18. 2 times what gives 18? 9. The next number is 3. 3 times what gives 18? 6. 4. 4 times nothing gives 18. 4 is not a factor. 5 times nothing gives 18. 5 is not a factor. The next number is 6. And once we realize that we already had that number, that means we've gotten to the end. 6. 3 times 6 is the same as 6 times 3. So we've gotten to the end of the factors. Now, the next thing is to get these factors out. So, for 6, it was 1, 2, 3, and 6. For 12, we have 1, 2, 3, 4, 6, and 12. For 18, we have 1, 2, 3, 6, 9, and 18. So what's the next thing to do? Remember, we are looking at highest common factor. We are first going to get common factors. What does common factors mean? Common means what we have here, and have here. What is common to all of them. So let's get the common factors of these numbers. What are the common factors of 6, 12, and 18? 1, okay, I'll pick 1. It's a factor, though 1 doesn't really change much. 1, the next one is 2. They all have 2, so I'll pick 2. What do they all have next? 3. So I pick 3. What do they all have next? 6 here, 6 is here, 6 is here. Good. There is 6 there. Of course, because they have exhausted all the numbers here, even if that number is here and here, it's still not going to matter. So we've gotten to the end of our common factors. Out of these common factors, which one is the highest common factor? 6. So 6 is our answer. That simple. Now, this is method 1. Let's go over to method 2. In this second method, we are going to separately express 6 as a product of its prime factors. Then we go ahead to express 12 as a product of its prime factors, and then 18 as a product of its prime factors. When we've gotten all the separate factors for 6, 12, and 18, we now look at which ones are common. Then we proceed to multiply them to have our highest common factor. Now, if you've not watched our video on how to express a number as a product of its prime factor, please go to our video on factors and prime factors, and then you understand how to express any number as a product of its prime factors. Let's proceed. So, we're going to start with 6. We're going to use only prime factors to break down 6. So what's the smallest prime factor of 6? Is 2. 2 goes into 6, 3. 2 can go again. We take the next prime factor, 3. 3 goes into 3, 1. So the prime factors of 6 are 2 times 3. We are done with 6. Let's go over to 12. The smallest prime factor, of course, that can go into 12 is 2. 2 into 12, 6. Can 2 still go? Of course. 2 goes into 6, 3. Can 2 still go? No. We go to the next higher number, 3. 3 goes there, 1. And then we have factors of 12 as 2 times 2 times 3. We are done with 12. Now let's break down 18 into factors. 2 again, 9. Can 2 again go? 2 can go again. We go to 3. 3 into 9, 3. 3 into 3, 1. Now 18 expressed as factors are 2 times 3 times 3. Now let's put them all together so that we can easily see the common factors. So which ones are common? We have 2. So we bring down 2 times 3. Is 3 common? Yes. We have 3 here, we have 3 here, we have 3 here. So our highest common factor becomes 2 times 3, which is 6. Do you see? It is the same as what we had in our first method. The same 6. Okay, let's go to the third method now. This third method looks like the second method, but it's easier and faster. Why? Because in this third method, we won't be wasting time treating each number separately. We'll put them all together in one place. And we will only pick common factors. What do I mean? We'll only pick a number that can divide 6, 12, and 18. So we are not picking all the prime factors only to sit down and check out which one is common later. We'll do the job here and right now. So which factor is common to both 6, 12, and 18? That is what we use in dividing. If that number cannot divide 6, 12, and 18, it is not a common factor and we are not going to pick it. So we start. What number can divide 6, 12, and 18? Let's start from the smallest prime number, which of course is 2. So can 2 divide 6? Yes. Can it divide 12? Yes. Can it divide 18? Yes. So we pick 2. So 2 goes into 6 is 3. 2 goes into 12 is 6. 2 goes into 18 is 9. What other factor can we pick? Can 2 still go? No, it can't go here. So we don't pick it. Once we find out that 2 cannot divide any of them, we don't pick such a factor. We go to the next higher common factor. 3. 3 can divide 3 years, can divide 6 years, can divide 9 years. So we pick 3. 3 goes into 3, 1, into 6, 2, into 9, 3. Good. What can we pick again? Nothing. We are already having 1. We've gotten to the end of the first number here, so we can't keep working. Even if we find a factor that goes into this and this, it didn't go here, so we've gotten to the end. So our highest common factor becomes 2 times 3, and that is 6. I told you it's easier than this. This is longer. This is very short. We stand at a point and then do 2 things in one. A factor and also a common factor. We use only common factors to divide. And then at the end we multiply them to get our highest common factor. I hope that was simple. So let's go to question 2. Find the highest common factor of 18, 24, and 42. And for the purpose of clarity, we are going to stick to our routine of method 1, method 2, and method 3. So method 1, what are the factors of 18, 24, and 42? Not prime factors this time. We're just going to run all the factors of each of them. And how do we get factors of numbers? By using our multiplication table. 1 times what gives 18? 1 times 18. The next higher number is 2. 2 times what gives 18? 2 times 9. The next higher number is 3. Does 3 times anything give 18? Yes. 3 times 6. The next one is 4. 4 times nothing gives 18. 5 times nothing gives 18. 6 times 3 gives 18. But we already have 3 times 6 here. So we've gotten to the end. Hit 6. So it means we've ended it. The next one is 24. We are looking for all the factors of 24. 1 times 24 gives 24. So 1 and 24 are factors. Next one, 2. We keep increasing this number until we exhausted all the factors. 2 times what gives 24? 2 times 12. Now 3. 3 times what gives 24? 3 times 8. Now 4 times what gives 24? 4 times 6. Does 5 times anything give 24? No. 6 times 4. But this is 6. So that means we've gotten to the end. Now 42. 1 times 42, of course. Does 2 times anything give 42? Let's see. 2 goes into 4 is 2. 2 goes into 1, into 2 rather, is 1. So 2 times 21 is 42. Does 3 times anything give 42? Let's see. 3 goes into 4 is 1. 1 will remain. 3 into 12 is 4. So 3 can go. And that is 1 and 4. Like we said. Does any other thing go? Let's try 4. 4 goes here, 1 can go here. 5 won't go. 6 goes into 42. If you know your multiplication table well, you know that 6 times 7 is 42. The next one is 7, and 7 is already here. So we've gotten to the end. So let's write out our factors, the factors of each of them, side by side. 24, 42. Let's write out all the factors of 18. These factors, these numbers, these are all factors of 18. For 24, these are all the factors of 24. These numbers are all the factors of 42. Let's write them all out here. The next thing is to find common factors. What are the common factors of 18, 24, and 42? 1, 2, 3. Remember, common means it must be here, here, and here. What about 6? We have 6 here. Do you have 6 here? Yes. Do you have 6 here? Yes. 6. What about 9? 9 is here. It's not here. It's not here. It's not a common factor. 18 is here. It's not here. It's not here. It's not a common factor. So that's the end of our common factors. Now, highest common factor. Out of these common factors, which of them is the highest? The highest number there is 6. So 6 is our highest common factor. Now, let's go over to method 2. Now remember, in method 2, we are only interested in the prime factors of 18, 24, and 42. And at the end, we multiply out our answers. So let's begin. What are the prime factors of 18? We start by choosing prime factors. 2 into 18, 9. Can 2 go again? No. We go to the next higher prime factor. 3. 3 into 9, 3. 3 into 3, 1. When once you have 1, we've gotten to the end of our division. The next one is 24. Again, we start with the lowest prime factor, 2. 2 into 2, 1. 2 into 4, 2. That's 12. The next, can 2 still go? Yes. 2 can go because 2 times something gives 12. So means 2 is a factor. 2 goes into 12 is what? 6. What is that number that divides, that 2 can multiply to give 12? It's 6. Again, can 2 still go? Yes. 2 can divide 6. 3, because 2 times 3 is 6. 2 can't go anymore. We go to the next number, 3. 3 into 3 is 1. For 42, 2. 2 goes into 4. 2. 2 goes into 2. 1. That's 21. Can 2 still go? No, this is an odd number. 2 cannot divide an odd number without leaving a remainder. So we go to the next prime number. Can 3 go into 21? Yes, because I know 3 times 7 is 21. 3 can go. 3 into 21, 7. 3 can go again, then, because this is a prime number. The only number that can divide a prime number is itself. So 7 into 7 is 1. Okay. Now let's list all this out. For 18, we have 2 times 3 times 3. So this way, you can easily spot out those ones that are common. So, what is common? 2 is here, is here, is here. So we pick 2. 3 is here. Is it here? Yes. Is it here? Yes. So we pick 3. Remember, in this method, we multiply out because we're using prime factors. So our highest common factor becomes 2 times 3, which is 6. Again, it tallies with what we had in our first method. Finally, method 3, which I recommend. I'm only using 1 and 2 to explain. I want you to stick to method 3. So as a matter of fact, our next example, we are going to be sticking to method 3. I said in method 3, we are going to place all 3 of them, 18, 24, and 42, all together. And then we only pick common factors. Remember method 2, you pick any prime factor and then sit down to find out the ones that are common. But right here, we are going to pick prime factor that is common here, and common here. If a factor is not common here and here and here, we are not picking it. So let's begin. Is 2 common to 18, 24, and 42? Yes. All of them are all even numbers, so 2 can divide all of them. 2 goes into 18, that is 2 times what gives 18, 9. 2 goes into 20, 2 goes into 2, 2 times what gives 2, 1. 2 goes into 4, what? 2. 2 times what gives 4, 2. So that's 12 for 24. 2 goes into 42. We do it digit by digit. 2 goes into 4 is what? 2 times what gives 4? 2 times 2. So 2 goes into 4 is 2. 2 times what gives 2? 1. So that's how we get that 2 goes into 42 as 21. I'm still trying to go back to that video so that you can easily divide. Please go and watch our video on dividing numbers easily, and then you'll be able to understand how to divide very easily. Can 2 still go? No. 2 is not common here, so I don't pick 2. So let's try 3. 3 can go here, can go here, and can go here. So let's pick 3. 3 into 9, 3. 3 into 12. 3 times what gives 12? 4. So 3 into 12 is 4. 3 into 21. 3 times what gives 21? 3 times 7. So it means 21 divided by 3 is 7. What can go again? Nothing. Nothing can go. This is a prime number. No other number can go into it. See another prime number here. No other number can go into it. So that means we've gotten to the end. So our highest common factor becomes 2 times 3, which is 6, as we had in the other 2 examples. If you have any question, kindly drop it in the comment section. For this next set of questions, we'll be sticking to just method 3. And like I told you, method 1 is just to help you understand where we are actually going. Now that you know where we are going, please stick to method 3. And that is what we are going to use in solving this question. So we begin. 21, 42, 63. We are going to stick to only common factors that are prime. Common factors that are prime. So we begin. Can 2 go into 21, 42, 63? Let's find out. Can 2 go into 21? No, it can't go. So already I know 2 is not a common factor, so I leave it. When once a number cannot go into all 3, I leave that factor. I go to 3. Can 3 go into 21? 3 times what gives 21? 3 times 7, yes, so 3 can go. Can 3 go into 42? Okay, assuming I don't know, let me try. 3 into 4 is 1. 1 will remain. I put the 1 here. 3 into 12 is 4. Wow, it could go, no remainder, so it goes. 3 into 6 is 2. 3 into 3 is 1. Wow, we found our prime factor, 3. So like we said, 3 into 21, 7. 3 into 4, 1, remainder 1. 3 into 12, 4, that's 14. 3 into 6, 2. 3 into 3, 1. Okay, we are done with that. Can 3 still go? This is a prime number. 3 cannot go. In fact, because this is a prime number, I don't even need to check 5, because no other number will go into a prime number except itself. So I only have 7 to check. Can 7 go into the rest? Because I know 7 can go into 7. Can 7 go into 14? Yes, 7 times 2 is 14. Can 7 go into 21? Yes, 7 times 3 is 21. So I pick 7. 1, 2, 3, like we said. 7 into 14, 2, 7 into 21, 3. Now, right now, we've gotten to the end of the first number by getting 1. So it means we cannot pick any other factor. So our highest common factor becomes 3 times 7, which is what? 21. I hope that is clear. Please, I want you to handle number 2. Pause the video and try it out by yourself before you unpause the video and find out how it is done. For those of us that have not paused the video, please pause the video and try it out by yourself. Practicing will help you. Now, if you've unpaused the video, you've done it, and then you have 15, kudos. But if you didn't have 15, don't feel bad. It simply means you have to watch the video again. Just go through the video again, and again if possible, and again until you get it right. I'm going to leave another question, and I'm sure after you've watched the video again and again, you'll be able to get the answer right. And finally, for this video, find the highest common factor of the following: 2 to power 2 times 5 to power 2 times 7. There's a power 1, but we don't write it. The next number is 3 to power 2 times 5 to power 2 times 7 to power 2. And the third number, 3 to power 2 times 5 to power 3 times 7 to power 3. Well, you might think it's complicated and different from what you've been doing, but it is not. By giving you these numbers in this form, they've already found all the factors of a certain number, and they are now giving it to you in this form. Remember this question? Find the H.C.F of 18, 24, and 42. And then what did we do with it? We found the prime factors of 18, 24, and 42, and we expressed them in this form. So what we are going to do with this question is simply write them out side by side like this so that you see the picture clearly. This is the first one, this is the second one, and this is the third one. Now, in case you are still confused because they are written in index form, what does this mean? This simply means 2 times 2 times 5 times 5 times 7. While 3 to power 2 means 3 in 2 places, 5 to power 2, 5 in 2 places, 7 to power 2, 7 in 2 places. This is this. 5 to power 3 means 5 times 5 times 5, 5 times 5 times 5 in 3 places, 7 to power 3, 7 times 7 times 7 in 3 places. Now, what will be our highest common factor? Our highest common factors will be those ones that are common. 2 is here, 2 is not here, I'm not picking 2. The second 2, 5 is here. Is 5 here? Yes. I can do that if I like. The next 5, do I also have a next 5? Yes, I also have a next 5. Now 7. Is 7 here? 7 is here, 7 is here, 7 is here. So I pick 7. Okay? See it here. 7 is not here. Even though another 7 is here and another 7 is here, which I can say this, but because it is not here, I can't pick it. Even when you have a third 7 here, there is no 7 here, and there is no, so I can't pick it. So we've gotten to the end of our answer. So I can choose to write my answer as 5 to power 2 times 7. Or I write it out. 5 to power 2 is what? 5 times 5, which is 25 times 7. And 25 times 7 is 175. That is our highest common factor. Now I will leave this one for you to try, and please leave your answer in the comment section. Find the highest common factor of 2 to power 2 times 3 times 5 to power 3, and the next number is 2 to power 3 times 3 to power 2 times 7, and the third number is 2 times 3 to power 4 times 7 to power 2. What is the highest common factor of this number, and this number? Please don't forget to subscribe to our channel. Click the subscribe button down there, or the follow button, or the like button. Thank you. Until next time. Bye-bye.